Welcome to the Air Force Training Corps. Here you'll be learning the basics of plane navigation and aviation in general. When flying a plane, you must take into account many key factors. These include the heading of the plane, or the actual direction that your plane is going, the course, the heading that you're attempting to follow, and finally wind speed. 30,000 feet in the air, turbulence can greatly affect the heading of a plane. A simple guess can either help or hinder a plane in its course. Fortunately, a way exists to accurately predict a course compensating for wind speed. This involves many geometric formulas pertaining to the trigonometry and law of cosines. To start, you must set up a coordinate axis with north at 0 degrees along the upward-facing y-axis going clockwise. Each axis is east, south, west, and west respectively. So bearing of 180 degrees would be south along the negative y-axis.
And now that we have bearings down, plotting a plane's velocity is relatively simple. To plot the course of a plane heading northwest at 100 miles an hour, draw a vector at 45 degrees with a measure of 100. Since wind speed is not yet introduced into this equation, this is also the heading of the plane. Now, let's have an example with wind. The plane is heading at 150 degrees with a speed of 150 miles an hour. There is a wind coming from the north with a speed of 20 miles an hour. Find the course of the plane.
So we can find the course by using the law of cosines, shown here. In this problem, we will use b squared equals a squared plus c squared minus 2ac times the cosine of b. In this problem, we will say that the heading is side C, the wind is side A, and the course is side B. From the problem previously, we know that C equals 150, A equals 20, and angle B is 150 degrees. So using this equation, we get that b squared equals 20 squared plus 150 squared minus 2 times 20 times 150 times cosine of 150. Or that b equals the square root of all of that. Solving this, we get that b, our course, has a speed of 153 miles per hour, but a course also includes a direction. By using the law of sines, we can relate proportions to accurately predict trigonometric values. The law of sines is sine of angle x over x equals sine of angle y over y. So by plugging in our earlier values, we can say that sine of 150 over 153 equals sine of a over 20. By solving this problem, we see that a equals 3.75 degrees. So finally, we see that our course is 153 miles per hour with a bearing of 153.75 degrees.
Well, students, we've taught you everything you need to know now. These essential techniques will make you successful in your career as a pilot, so make sure to keep them in mind. In high school, you may have been sitting in class thinking how useless this stuff was, but look at you now. Who would have thought these things would be applicable in real life? My best wishes, pilots, and I hope to see you in the sky someday.